All right, hello everyone, and welcome to Intro to Java. So the we've done some TypeScript stuff before, so we're familiar with like static typing, which is awesome because I think that's like a lot of the hardest stuff about this. We're also used to having a compilation step now, which is also like gonna help a lot. But Java is way stricter about lots of things. And so a lot of our discipline that we were developing over TypeScript is going to come in handy. So let's do a quick overview of the Java platform. So Java the language was, I want to say, 1995, thereabouts. Might have been 1994, but somewhere in there. Um, and it was an attempt to have a modern OO language. So the most popular object-oriented language before Java was one called Smalltalk. And so Java was really kind of replacing Smalltalk in a way. It was an instant hit, overnight success. People went bonkers for Java. And even like JavaScript, which came out the same year, was named JavaScript as like an intentional like marketing trick to like trick people into thinking JavaScript and Java were related because Java was so popular. Other than like those both being C family languages, I can't say there's like a whole lot that they have in common. And then like a part of the modern part of this was write once, run anywhere, or WARA. So when you write Java code, actually let me roll back. When you write something like C++, like you have to like target specific machines and stuff that can execute those. So like if I write some C++ and compile it, like I need to compile it separately for this processor and this processor and this processor. So my computer and your computer like need to compile this code independently for each of those platforms. That sort of sucks. So with Java, we have like an in-between thing. So Java, we compile to the bytecode. And then instead, each of those has the JVM on them, and the JVM can run Java bytecode. So there's no extra compilation step. It's not compiled differently for a car versus a watch versus a smartphone versus the web. All of those different hardware environments run the JVM, and the JVM can run Java bytecode. That was the magic. That was the modern part that they were looking for in Java. So did they succeed? Kinda. I don't think it's quite the. I think really the web ended up being the write once, run anywhere that Java was always trying to be, because if something runs a web browser, it runs web apps. Like that's that same principle that they were going for. That was not a glimmer in anyone's eye in 1995. And so, in my opinion, I think the web actually fulfilled that WARA promise, but that was the design goal of Java. And so it's one of the reasons it has all these layers of abstraction on it, is to support this idea that the same code, the same compiled code could run natively on a bunch of different platforms. Also, if you remember computers from once upon a time and you're like, oh, I need to install Java to run this thing, that's what you were doing, was like installing the JVM so that the Java bytecode could run on your computer. Okay, I'm going to pause there. Ask me some questions.
Because the only reason JavaScript didn't get sued out of existence is because it was 19 whatever.
We had lawyers back then. I don't know how long ago you think 1995 was.
No, I mean, where sometimes things aren't properly protected by patents and trademarks when they first come out. So
Sure.
that was kind of what I thought.
Yeah, I'd say that's like, and for all I know, they did get sued and then just came to an agreement. Like, that sounds likely. And also, like, we call it JavaScript, but that's not the name of it. It's called ECMAScript. That's why we can say like ES 2015 and all those kinds of things, because of that trademark issue. And even like JavaScript was owned by Netscape. There was a product that Brendan Eich made for Netscape. And so like they own that trademark. And so they were the ones who like slugged that out with Sun, who owned Java at the time. And now it's owned by Oracle. And so when they like published the open spec for JavaScript, they published it as ECMAScript. ECMA is the standards body that has that owns the specification. So yeah, anytime you see ECMAScript, that's what they're talking about. It's the same shit. We just can't call it JavaScript, but I can call it JavaScript. Come at me, Oracle. I dare you.
Very fun. Thank you.
I'm starting to get more curious about C++. It seems like a lot of tools and frameworks and everything are built with C++. It's like it's at the heart of everything. I don't know much about it, but
sure.
now I feel like I'm going to go Google it.
So, like, minor tangent, you are correct. It is like C++. One of the things we get with that, more so than Java, definitely more so than like our super high level stuff like JavaScript, we get more access to how the computer does stuff. So like in Java, we don't worry too much about how to assign a variable. We go, hey, give me a variable. Done. In C++, we need to like allocate space in memory to like actually put that stuff. And then when we're done using it, we need to tell the computer that we're not using that anymore. And so it's a lot more fiddly with that kind of thing, which gives us a ton of control. We can use that to make things way faster. But you would never write an application in C++. That would be insane. So you mostly use it to write a platform that you can write an application on. So for example, the browser. Browsers are like generally written in C++. And so that's the thing that's executing your JavaScript code.
Okay.
Also, like it's been taking a beating lately because like C++ is pretty old. Goes back to, I want to say late 70s, early 80s. Bjorn Storstrup is the guy behind that. Still is to this day. James Gosling, also the guy who made Java, still involved with all that. Bjorn Storstrup. Here's the C++ guy. And it's actually taken a beating lately because it's kind of old and it has some shortcomings. So Rust is kind of the targeted replacement for like low-level programming. Rust is a lot newer. Like Rust happened in my timeline. So I first started hearing that about like 10 years ago or so. I know that Yehuda Katz, who was the guy who made Ember, was pretty actively involved with that. The Mozilla Foundation was pretty involved with Rust. And now I'm starting to see it pick up. So for like systems level programming, Rust seems to kind of be where the wind is blowing.
Okay.
Other questions so far?
Was Java like a natural progression of Smalltalk, or was it just something completely different?
Great question. Natural progression. So
Okay.
Java adds a ton of ideas on top of Smalltalk, not all of which were popular, but all of which won. Because I still see COBOL postings and stuff, and I think Julie's dad does COBOL, or Sharon's maybe. But I have never seen any Smalltalk stuff my entire career. I just see like remnants of it, like the Gang of Four book. All the examples are in Smalltalk. I think that's most people, myself included, only exposure to that language.
Thank you.
Yeah. More questions so far?
What would you say the primary application for Java is that you see, as far as
Sure.
what is it mostly being used for?
So that's a great question. So languages are kind of like tuned for different sorts of things. So JavaScript is like one thing and one thing only: browser programming. So it is optimized for that. The way that it handles asynchronous code is designed around how, like, just the asynchronous nature of the web. And even as it's grown up, and like the purpose of Node was to take JavaScript out of the browser and just turn it into a general purpose programming language. But you still see its roots and how you write JavaScript. There's other like very specific languages like SQL. SQL is databases. The end. You wouldn't use SQL for anything else. Like doesn't even make any sense. CSS is a markup language for browsers. So all of those are like very narrow purpose kinds of things. And then we have what are called general purpose languages. So general purpose language can be used for any programming task. So that includes Java, Python, Ruby, I guess I would call Go a general purpose language. Scala. All of these are just, do you need to tell a computer to do something? Here's a language that can do that. Now, these have different ways of structuring code, like Haskell, for example. Haskell is a pure functional language, which means like it doesn't have if statements. You can't store things in variables. Like there's like pure functional stuff. And so like if you would like to organize how you're telling a computer to do something in a pure functional manner, Haskell might be a good bet. On the other end of that, if you want to do it in a pure OO way, hard to go wrong with Java, although if you feel like Java is too verbose, like most people do, like that was one of the goals of Ruby, was to have like a modern object-oriented language. Doesn't have the write once, run anywhere kind of idea, but is way, way, way less verbose than Java. It's also statically typed, but it's not strongly typed. You don't put the types in when you're writing your code. And so and then Scala kind of splits the difference. Scala runs on the JVM, so you do get the write once, run anywhere thing. And it's a little bit object oriented and it's a little bit functional. JavaScript's the same thing, especially TypeScript. Where like we can write in a functional style or we can write in an object oriented style. And I think like advocates for both of those paradigms would say that like it doesn't do it flawlessly, but allows you to sort of jump back and forth. Go, on the other hand, pure procedural. Like there is no abstraction in Go. Like, oh, you need to loop something? Here's your one loop. You need to do conditional logic? Here's your one way to do that. Like there's barely functions in Go. Like, 'cause you have to write everything out very literally by hand. Now, the trade-off with that is that it's fast as shit. And also, teams that write Go code find that, like, not having all those abstractions, it's a lot less stuff to kind of get tripped up on. And so a lot of teams find that they're more productive just writing pure procedural code. So all of these are general purpose languages with a different bent. So, like, where do I see Java in practice? It's probably more popular than all of these put together. But, like, if you had to program something for, like, let's say a car, like navigation system or something like that, Java's a probably safe one to reach for. If Android native code is all written in Java. I don't see it as much on the web now as I used to, except for Spring Boot. And, like, I really only see Spring Boot at a certain scale of company because it's more efficient than, like, the equivalent, like Rails would be a direct equivalent to Spring Boot. Spring Boot is a lot more efficient than Rails. So if you're running a shit ton of servers, it costs less money to run them if they're written in Java versus Ruby. Now, like, you might say that the productivity gains that you gain from, like, writing something in a language like Ruby outweigh the cost of running the servers. That's what GitHub decided. GitHub is one of the most trafficked websites on the entire internet. And the entire thing is just a Rails app. And so how do they get around how much less efficient it is than something like Java? They just pay more for the servers. But their developers get so much more done that they end up saving money in the big picture. All of these kinds of things are trade-offs that you make when you're picking a language for something. Sometimes you don't get to pick the language. Like in these cases, if you're writing for the browser, one way or another, you're writing JavaScript. You might be writing something that compiles to JavaScript, but that's the only language your browser speaks. If you're writing a shell script, like an installer or something like that, I don't know, maybe one of these makes more sense.
I remember it was a big deal when Microsoft bought Minecraft and they started rewriting the game in a different language because it was written in Java originally, and they said it's because it was slow. Is it for the opposite reason that you said Go is fast?
Yes. So, like, that's all levels of abstraction. So down at the very bottom, we've got, like, Rust, Go, C, like C++ would probably be, actually, I'm going to put Rust and C down here, right above them, C++ and Go. These are, like, as fast as you get. And then up here, we have, like, the slowest stuff. So slowest stuff would probably be, like, JavaScript. Because, like, when you write JavaScript, it needs to get run by another language. So it's always going to be slower than just running that language. So JavaScript would be up here. I would say Python and Ruby and PHP. Those compile a little bit differently than JavaScript does. So I'm going to say they're a tiny bit faster, the same way that I think these are probably a tiny bit slower than Rust and C. And then we have a landscape in between here. So, like, I don't know what they rewrote Minecraft in. I'm guessing C#.
I think so, yeah.
Let's see. Minecraft rewritten Java. No, it looks like they rewrote it in C++.
Oh,
So there you go. I was going to say, that would be a little wild if they'd rewritten in C Sharp. Because C Sharp is effectively Microsoft's version of Java. Java is owned by Oracle. C Sharp is owned by Microsoft. They are very similar languages. If you know one, you kind of know the other one mostly already.
really?
Um,
Yeah, all right.
But yeah, there you go. Like C Sharp is Microsoft's object-oriented language that is designed to write once and run everywhere, like that kind of thing.
Concerning the bytecode,
Mm-hmm.
that's going to, if I read it correctly, is going to be the machine language. So it's literally just the bleeps and bloops that's going to be able to compile it into a different machine, right?
Not quite. So what happens there is you write human readable Java source. That gets converted into bleeps and bloops. That's the bytecode. And then the JVM that's running on that device reads that directly. And so then the JVM takes those bleeps and bloops and it converts it into the specific kind of instructions that piece of hardware needs.
Awesome. Thank you.
So is JVM and is the same thing as compiler, or is it two different things?
Two different things. So
Okay.
let's go over those three acronyms. They're super confusing. If they're not like immediately clear to you, it's because you have 2 ears connected to a heart. It's unnecessarily confusing. So from an install standpoint, the JDK was the thing that all of you like installed to get Java. Not everybody needs that. This is the thing that has like the Java C compiler. You only need that if you need to be able to compile the code yourself. Most people don't. Most people just run the code. And so you can run the code with the JRE via the JVM that it installs on your computer. So the JVM is the thing that's running on your computer and is like translating the Java bytecode. The Java C compiler creates that bytecode. The JRE is like the stuff that you didn't write. Like system.print.out or whatever, like you didn't write that code. All of that is a part of the JRE. So your code is being compiled in context of the JRE, and then it's being run by the JVM. A developer installs the JDK. A normal human installs the JRE. It's not mission critical that like you could write a thesis on the difference between these three things, but that's what they are.
I just got stuck on the compiler vocab word and I'm going, isn't that the same as JVM? But I'm glad it's not. So now I have to go look for it.
So yeah, the compiler turns our source code into bytecode. So I'll show you an example of that in a second, but other questions about high-level Java stuff? Cool. Let's take a look. So same caveat as with Angular. I am not a Java expert. I've actually been teaching it for a couple years, but it's it's not something that I use that much outside of teaching, and so it's one of those things I have to like kind of relearn every time, but I think we'll be all right. So if I go into projects, practice, let's make a new, and feel free to follow along with me on this part. So we'll do like a Java demo. So empty folder, nothing up this sleeve, nothing up this sleeve. Shh. Shh. There we go. All right, so we are going to make a Java file. We'll call it capital A app.java. Just like that. And then we're going to open that up. And we're going to do a hello world. So everything in Java happens in classes. I can't just write code here. I can't do like system.out.println hello world, because it's not inside of a method. Any code that you want to run has to be there. There is no such thing as a standalone function. There is no such thing as like just writing code out willy-nilly. Has to be inside of a class. That's what makes something object-oriented. Like TypeScript is object-capable, but it's not object-oriented because you can do a whole lot of other kinds of things. This is an object-oriented language because it's the only way you can write the code. So we're going to make a public class, and it's going to be called app, because that's the name of our file. Java code is like coupled a little bit more to the files that it's in than anything else you've done. The file names matter more. In general, whatever the name of your class is, including the capitalization, that should be the name of the file also. So then we're going to make a method called main. And there's a magical incantation that we do for this. Public static void main string args. So some of this we should be able to figure out from TypeScript. It is a public method, not a private method. It's static, so it's part of the app class itself, not like an instance of the app class. By the way, static methods are the closest thing we get to just standalone functions. And oh, I guess lambdas would be, those are literally standalone functions. But by and large, a static method is like equivalent of like just a regular JavaScript function. Void is the return type. The method's not going to return anything. Main is the name of it. Every single Java application needs to have a main method. That's the entry point. When you run the app, that's the thing that's running. That's the data type. That's the variable name. So if I were writing this out in TypeScript instead, it would look like this.
Are all the variables called args? Or is that something?
Just the one that you're going to call, just the one for the entry point. So
Okay.
like if we call this on the command line and then pass things into it, those are available in an array that's called args.
And also, do we need to create an
Sorry,
app.class?
No, we don't.
Okay.
So, one more thing. This is an array. You get an array of these back. So if I wrote that same thing in TypeScript, it would look like this. I guess I could annotate the return type too. TypeScript, Java. It's not night and day different. Just a little bit more verbose. Questions?
So Java can't infer public methods and stuff. We have to put it.
Java can't infer shit. One of the things that takes people probably the longest, I think, to just get used to seeing in Java syntax is the prefix types instead of the postfix types. Return type goes before the name of the method. Parameter type goes before the name of the parameter. Cool. All right, so your screen should look like my screen. And then we're going to do the equivalent of a console log. So in Java, that's system with a capital S dot out dot println. Notice that the L is not uppercase. Println is not like a camel case method. It's all lowercase. So we do that. And that's our Java source code. To do anything with it, we need to compile it. So to compile it, I'm going to run Java C, it stands for Java compiler, then the name of the file. If you got an error, that means there's some syntax issue there. My guess would be you forgot this semicolon. Hopefully your text editor just added it for you. Semicolons are absolutely not optional in Java. Every statement needs to end in one or it's a compiler error. But let's take a look at what happened when I ran that Java C command. Dun da da da! I got that app.class file. The class files are the bytecode. Like if I try to open this in a text editor, jimble jumble.
Can you pause for some help? Like whenever I ran the Java C app.java, it just returned the command line again. It didn't do anything.
Yeah.
But if I ran Java app.java, it says error, class found on application class.
Correct.
App.
Because you can't run Java on a Java file.
Okay. So do you know why it wouldn't have run with the Java C app.java?
No, it doesn't return anything. Didn't do anything here either.
Okay. Okay,
Yeah.
gotcha.
So when I do this, that means it was successfully compiled.
Okay. Sorry.
Now, no, this is exactly what we're here for. So to run this file, we do Java, and then the name of the class file, no extension. So like right now I have these two files in here. If I want to run this, I do Java, capital A, app. And that's it.
Can you go back to your Java document for just a second?
I'd love to.
Is there any rule or
Thank
reason
you.
why the print line method is all lowercase?
I don't know. it's like there's a couple of these conventions that I think have a little bit more going on than at first blush. Like, for example, having all lowercase package names. That's not as dumb as you might think. This, though, I think that might just be stupid. More questions so far?
I got the app.java is a non-project file, only syntax error are reported. Is that just because I didn't capitalize the app thing?
You have to capitalize class names.
That's what it is. Okay, thank you.
Been telling y'all for 13 weeks now, don't go rogue on naming conventions. Java in particular doesn't play, man. It's going to punish you for it. Other questions so far? Cool. Let's say I wanted to have another, like maybe that string comes from another class. So it'd be something like message.java. So make a file called message.java. Okay, public class message. And for this one, I want a constructor. So it'll take in a string and then save it to a property. So it's going to have a private property that's a string prefixed, remember? And it's going to be called content. The way that constructors work in Java, they don't use the constructor word like we did in TypeScript. They're the name of the class. So if I have a method that's like public void message, and I make a method out of it, that's a constructor. And then if it takes in a string that's the content, and I do something like this.content equals content. Why is it so mad at me? And I don't need the return type on constructors. Duh, come on. That's why. All right, so if I make a constructor for that, now I can do something in my app.java file, like import that class. So like import message. Do I need to say default? Nope. All right, here's a good way to find out. What if I just try to use it and have the text editor figure out how to import it? You're gonna have to import a lot, like a lot of shit in Java. It's usually better to just let your text editor like do all of the work for that. So if I try to make a new message, Oh, I don't need to import it because they're in the same package. Duh, that makes sense. Cool. So that's how we do variable assignment. We don't have like a var or a const or a let. You declare it with the type of whatever the variable is. It's going to be of type message. Its name is message with a lowercase m. We say new, and then we pass in that string. That gets set to the content of that. You cannot access, or you should not, access properties directly in classes. Always go through getters. And so the way that we do that is by saying like public string get content. And that format, that's also not one to like overthink. Take whatever the name of the property is, put the word get in front of it. Move on with your life. Don't get any more clever with it than that. And then have it return this dot content. And then to use that, over here we can say something like message.getContent. And if I compile this thing again, and try to run it, it still works. I have two classes. This message class takes in a string, saves it as a property, adds a getter for it. The entry point of the app makes a new instance of that message, and then prints the content of that instance.
I'm sorry, how did you compile it? I missed it, sorry.
Same way as before. Java C app.java to compile, Java app to run it.
So will that compile both the app and the message files?
Oh shoot, good call. Yeah, I assume that it did because it like probably went through the dependency graph on it. The hack on that though is change that to star.
Okay.
There you go. I have class files for both of them.
And
class
that,
files with that
VS
bytecode, and that's what the JVM is going to run.
The VS Code trick that you posted in the queue earlier just keeps it running.
Oh, it does?
Like I didn't have to run it again with the new file.
Beautiful.
Yeah, so it just has that little run and debug in it.
So that was a Shift-Alt-B in VS Code. Should like continuously recompile your stuff.
Can I see your app Java file again?
Love to.
Okay.
So are we actually supposed to create a new file for each and every class?
Every single class should have its own file.
And so I noticed that when I was doing it earlier, I didn't kind of make that connection of the class name and the new files. And I had them all on one page and it was fine. It was just creating new classes off to the left until I started to get complicated with it, with extending.
Yeah,
So
it's less of a rule and more of a convention that is followed across the Java universe.
So you could just have like a billion classes over there and you just have to be able to find them?
Yeah.
That's great. Cool.
And like Java has a pretty complicated system and convention for how it works with these in the wild. So like I'll show you a real, like a Spring Boot app.
Just real quick.
Yeah.
What is the purpose of the message equals new message? Like if you put in a different string in there, and then you run it again, it still shows the original.
Probably because you didn't recompile.
Okay.
So if I recompile that and then Java app, goodbye home.
Okay.
But yeah, like until you recompile it, it's that same class file, and that's what's being run by the Java command.
Can I see the message.java? Sorry, it was going fast back between everything, and I'm just behind.
So it has a public constructor, takes in a string. That's what was happening over here. We take that string, we save it as a private property over here, and then we make a public getter for that property.
And if you get whenever you try to do the compile and you get an error message, it says it says the new on the message equals new message. It said it can't be applied to the given type.
Okay, why don't you screen share? Let's take a look.
Okay.
All right. Oh, your text editor's mad at you. Yeah, this message.java, that's not in your folder. Why doesn't it in your text editor?
It's right here.
No, but I mean in your Java Hello World exercise on the left.
Oh, I don't know.
She didn't drop the void. She didn't drop the.
Oh yeah, get rid of that.
Remember, you
void.
went back and you said you had to drop the.
Yeah. But also, yeah, you've got a Java practice folder and you've got this Java Hello World folder. And like, since we're using VS Code more like an IDE, like we got to get this stuff right. So, Sharon, why don't you close both of those tabs? Close the whole text editor. And then over in your terminal, do a code dot. Yeah. That's going to help your text editor figure out which things go together. Because like what it does in the background is it's like compiling this stuff for you, sort of, kind of, and like it's making the connections between all these things for you. So let's take a look at the app.java file. All right, no red squigglies. That's what we like to see. Now let me see your message.java file. Nope, not the class file.
Oh, sorry.
All right, that's looking a lot better. So now on your terminal, try recompiling that with Java C and then star.java. Yeah. And now run Java app with a capital A.
Okay.
There you go.
Thank you so much.
You're very welcome. Other questions so far? So that's kind of like the gist of Java and how it works. Like a really good resource, I think I have it linked in the LMS, but every single time I need to either learn a new language or remember how to use a language I haven't used in a long time, is this site. I may have sent you there before, called Learn X and Y Minutes. This stuff is the Rosetta Stone for programming languages. So if we go down to Java, like it's a perfect example. I was helping Kim with a Go interview practice like a while back. And like I've done some Go stuff before, but like not a ton. It's been a while. And so the very first thing I did was just like go through all of this and reacquaint myself with how their syntax works. But it's all of them are just one long file that have examples of all of the language features. So like comments, import statements, classes. But yeah, reading through this, you'll see everything that's in the language this way. All right, so a real Java app looks kind of like this. So the main class on this is Barkwire application. So like that's the entry point for a Spring Boot app. And then the actual class files, sorry, like lowercase c, or no, uppercase C class files look like that. It's all the same stuff. You can see how like verbose it gets. You can also see how, like, just for this file, that's all the stuff that gets imported. So like nobody wants to type all that crap out by hand. Like figure out your VS Code shortcuts for like, the way it works is whenever you use one of these, like if I didn't have this delete mapping thing in there, it gets mad at me and goes, hey, you don't have a delete mapping. And so then I run my little compiler tool and say, oh, can you import that for me? And then it gets added. Yeah, you always want to be using your editor tools for stuff like that. You will type it out wrong. So in this one, lots of the same thing. The one thing that's a little bit different when we get into Spring Boot is these things. In TypeScript, those were decorators. Just to make this as confusing as possible for you, in Spring Boot, these are called annotations. They function very similarly. They have magic behind them that does magic things to the classes or variables or properties or whatever. Don't worry too much about them past that. This says, hey, it's a controller. That's the URL that it goes to. That's dependency injection. There's like a lot of like really similar ideas, just a slightly different syntax. And then when you run one of these, let's see, this one is Maven, so it's MVNW Spring Boot run. So that's the equivalent of like an npm start kind of thing. And so it does all that, compiles all my stuff for me. This also does like auto recompiling anytime you change one of the files. And awesome. So that's running on port 8080. And if I head over to localhost 8080 API/dogs, that's reading out of my database. I could deploy this on the internet. In fact, I think I did. As it wakes that up from its angry slumber. That's reading out of the production database. So where we're going in this unit, you need to get comfortable with this Java syntax. You don't need to rock at Java development. I have some of those like other exercises to give you a lot of opportunities to practice and stuff. But the things that we were just doing in that Hello World stuff, that should be under your fingers. So like the public and static and new and ending stuff with semicolons, like that stuff you should be pretty solid on. Writing Java apps, that's out of scope for this. It's more like, can you write Java code without like tripping over your shoes? And then our SQL stuff, completely unrelated. And like it's pretty light. There's like 4 or 5 things that every developer needs to know how to do a SQL. And you've got a pretty battle-tested way to learn how to do those. And then Spring Boot, I'll show you. Basically need to make that Barkwire app, but I really tried to make it as easy as I could. So this has like step-by-step guide to everything that you need to do to make a Spring Boot app. And like, if you can sort of get by with the syntax, I think you'll be all right. Follow all those steps, you will have a deployed API. And so your final project is, you probably should have seen this coming, the Pokemon API, except you got to make the API this time. So that looks like this. So I give you some data, and you got to figure out how to put that in an API following the instructions. And then when we're doing our capstones, you'll do that same thing. You'll make an API, you'll have it store data, and that's it. That's what we're doing. Questions?
So Kyle, I'm getting a few interesting errors. Would we be able to take a
Love
look at
it.
it?
Fire it up, baby.
Awesome. Oops, sorry guys, 1 second. Right here and Shazam. Awesome.
All right, so oop, I see it. It's on line 2.
Got the void in there.
Oh, did it again. Look at that.
No, that one needs to be there. Because it's not a constructor.
Right.
Args needs to be next to string,
Julie found it.
not separate.
I see. So args goes in here. That's our parameter. I see. Awesome. Thank you. That cleared it right up.
Pew! So that's the kind of stuff that we have like 2 weeks to get comfy with. If you can do that, I think you'll be able to pair on a Java code base just fine. What else?
I know a fellow that works for Oracle, and this morning I asked him for some advice when working with Java, and he told me to go get coffee.
Yes. Yeah, it's pretty punishing for like an early language. I think you guys have the absolute best preparation you could possibly have, though, because so much is similar to TypeScript, and like I've been so mean about how I evaluate your stuff, and so I think you'll do okay. I'm gonna add a couple more practice things too, totally optional, but the in the Java section of the LMS. Down at the bottom, I'm going to add a few more of these like exorcism style things. So these work exactly like the ones before. In fact, like I think it's even okay if you want to like try referencing your other logic for how you solved it before and see if you can translate it to Java. I don't have any issue with that. And then this test command, if you run that, that handles everything else. So including like your compilation and what have you. So over in triangle. Oh, it's still in exorcism. So if I do a dot/test in here, it tells me, hey, all your tests are failing, and it waits for me to try to fix it. And if I go over to the solution, I do that same thing. I see fields of green. So there's some more opportunities to work on your syntax too. Awesome. Anything else we should talk about before I cut you loose for a little bit? Have fun.